Have you ever wondered why two bakers can use almost the same recipe, yet one produces a soft, fluffy cake while the other ends up with a dense and dry product? The secret isn't just in the recipe, it's in understanding the role of each ingredient. Every ingredient in bakery and confectionery has a specific scientific function, and mastering these functions is the key to becoming a successful baker. Let's explore these fascinating building blocks together. I hope you're all doing well. In today's session, we are going to study the basic ingredients used in bakery and confectionery products. We will understand the role of flour, sugar, shortenings, eggs, milk, water, salt, and leavening agents. We will also explore the different types of sugars, their manufacturing process, and their applications in bakery products. By the end of this lecture, you'll not only understand these concepts clearly, but also be able to relate them to practical baking and university examinations. Today's topic is Ingredients in Bakery and Confectionery Part 1, The Building Blocks. In this session, we will understand how every ingredient contributes to the quality, texture, flavor, appearance, and shelf life of bakery products. Although bakery recipes may appear simple, each ingredient performs a unique scientific function. Understanding these functions helps us prepare consistent, high-quality products and also forms the foundation for advanced bakery technology. Let us begin our discussion. Before learning individual ingredients, let us first understand the basic ingredients used in bakery and confectionery. The core ingredients include flour, sugar, shortenings, leavening agents, eggs, milk, water, salt, and milk. Each ingredient performs one or more important functions during preparation. The first category is structure builders. Structure builders provide the body and framework of bakery products. Ingredients such as flour, eggs, and milk contribute to strength and help the product maintain its shape after baking. The next category is tenderizers. Tenderizers make bakery products softer and more pleasant to eat. Ingredients like fats, sugar, and certain leavening agents reduce toughness and improve tenderness. Another important category is moisteners. Moisteners help retain water within the product, preventing excessive drying and improving freshness. Water, milk, and syrups are common examples. Finally, we have dryers. Dryers absorb and retain moisture, helping maintain the desired texture. Milk solids and starches are good examples of ingredients that perform this function. As we continue through this lecture, you'll notice that many ingredients actually perform several of these functions at the same time. Let us now begin with one of the most important ingredients in bakery science, sugar. Sugar is often called the soul of desserts because its role extends far beyond simply making food sweet. The first point tells us that sugar is a vital ingredient. Sugar is one of the cornerstones of the bakery industry. Besides providing sweetness, it contributes to structure, color, moisture retention, and product stability. The second point explains that sugar is a natural and pure substance. Chemically, sugar is a non-toxic, water-soluble, concentrated crystalline carbohydrate. Because it dissolves easily, it is widely used in almost every bakery formulation. Next, the slide introduces simple sugars. Simple sugars are known as monosaccharides. Common examples include glucose and fructose. These sugars consist of a single sugar unit and are easily utilized by the body. The final point discusses complex sugars. Complex sugars or disaccharides consist of two simple sugar units joined together. Maltose and lactose are examples of disaccharides commonly encountered in food science. You can also observe the chemical formula of sucrose, C12H22O11, which indicates that sugar is composed of carbon, hydrogen, and oxygen. This basic chemical composition explains many functional properties of sugar during baking. Now that we understand what sugar is, let us see how it is manufactured on an industrial scale. The first step is extraction. Sugarcane or sugar beet is crushed to extract the raw juice containing dissolved sugars. The second step is refinement. During refinement, impurities are removed using substances like lime or carbon dioxide. This produces a cleaner sugar solution. The third step is crystallization. The purified juice is concentrated by boiling under vacuum. As water evaporates, sugar crystals begin to form. The fourth step is centrifuging. A centrifuge separates the sugar crystals from molasses using centrifugal force. This produces raw sugar crystals. Finally, comes purification. The sugar undergoes additional bleaching and filtration to produce the white refined sugar commonly available in the market. The flowcharts shown on the slide illustrate this complete manufacturing process from sugarcane to finished sugar, helping us visualize each stage of production. Take a moment to remember these 5 steps as they are frequently asked in university examinations. Having understood sugar manufacturing, let us now examine some common forms of sugar used in bakery products. The first type is granulated sugar. Granulated sugar is the standard white sugar used in most households and bakeries. It contains approximately 99.7% pure sucrose. Because its crystals dissolve easily in recipes containing sufficient liquid, it is suitable for cakes, cookies, beverages, and many everyday bakery products. The next type is icing sugar. Icing sugar is prepared by grinding granulated sugar into an extremely fine powder. A small amount of cornstarch is added to prevent the powder from clumping during storage. Its fine texture makes it ideal for cake icing, frosting, decorative dusting, and smooth cream preparations. The image on the slide also compares different forms of sugar, allowing us to observe differences in particle size and appearance. Just like coarse and fine sand behave differently, different sugar particle sizes also influence the texture and appearance of bakery products. Moving further, let us understand some specialty sugars that are designed for specific bakery applications. The first is castor sugar. Castor sugar is an extremely fine form of sugar, often called breakfast sugar. Because it dissolves very quickly, it is especially useful for preparing tender cakes, sponge cakes, and meringues where a smooth texture is required. The next variety is pearl sugar. Pearl sugar consists of large polished crystals that resemble tiny pearls. Unlike ordinary sugar, these crystals retain their shape during baking, making them ideal for decorating buns, pastries, and specialty baked products. The final variety is sugar cubes. Sugar cubes are prepared by moistening sugar granules, pressing them into molds, and allowing them to dry. They are commonly used in beverage service because they provide convenient portion control. Each variety of sugar has been developed to meet a particular baking or serving requirement, demonstrating that selecting the correct ingredient is just as important as following the recipe itself. Building on our understanding of specialty sugars, let us now examine sugars that differ in fineness and texture. The first type is powdered sugar, also known as confectioner's sugar. It is prepared by pulverizing granulated sugar into an extremely fine powder. Because of its very fine particle size, it dissolves almost instantly and produces exceptionally smooth icings, glazes, fondants, and frostings. Another important characteristic is its versatility. Powdered sugar is manufactured in different grades of fineness depending on the requirements of various confectionery products. Next, let us understand brown sugar. Brown sugar is prepared by adding molasses back to refined sugar. The molasses gives brown sugar its characteristic color, aroma, and rich caramel flavor. Another important property is its moisture-retaining ability. Although it may form small lumps during storage, this moisture helps cakes, muffins, and cookies remain soft and fresh for a longer time. Brown sugar is therefore widely used in rich cakes, puddings, cookies, and baked products where enhanced flavor is desired. The next important group of ingredients includes glucose and its derivatives. Let us first understand natural glucose. The commercially available form of glucose is called dextrose. It occurs naturally in fruits and is also present in the human body. One of its major advantages is its excellent moisture-retaining capacity. This property helps bakery products remain soft and fresh for longer periods. Glucose also clears crystal control. It regulates sugar crystal formation during confectionery manufacture, producing smoother candies and syrups. Glucose also serves as an excellent food source for yeast during fermentation, helping bread dough rise properly. The second derivative is liquid glucose. Liquid glucose is produced from cornstarch through acid hydrolysis. Unlike crystalline glucose, it is a thick viscous liquid. Its major function is preventing unwanted sugar crystallization during confectionery manufacture. It also acts as a natural preservative by maintaining moisture and improving the shelf life of many bakery and confectionery products.
Having understood glucose and its derivatives, let us now explore other important sugar products used in bakery and confectionery. The first product is liquid caramel. Liquid caramel is a thick, free-flowing syrup that gives bakery products a rich brown color and a pleasant caramel flavor. It is commonly used in puddings, confectionery products, bakery fillings, sauces, and beverages where both color and flavor enhancement are required. The next products are treacle and molasses. Treacle and molasses are valuable byproducts obtained during sugar refining. Although they are darker in color than refined sugar, they contain characteristic flavors and minerals that improve the taste of cakes, cookies, breads, and certain confectionery products. Another important sugar discussed is maltose. Maltose is commonly known as malt sugar. It is produced during the breakdown of starch and plays an important role in brewing and fermentation. Because yeast can easily utilize maltose, it contributes to proper fermentation and flavor development in bakery products. The next sugar is lactose. Lactose is commonly called milk sugar because it is naturally present in milk and is commercially obtained from whey. Although lactose is less sweet than sucrose, it contributes to browning reactions during baking and enhances the flavor of dairy-based bakery products. The final product shown is golden syrup. Golden syrup is a thick, amber-colored syrup with a pleasant honey-like flavor. It helps improve moisture retention, softness, and flavor in cakes, biscuits, and confectionery items. When you compare these products, you'll notice that each one contributes something different. Some mainly improve sweetness, while others enhance color, flavor, texture, or shelf life. Building on our understanding of different sugars, let us now study invert sugar and some of its important substitutes. The first product is invert sugar. Invert sugar is produced by breaking sucrose into equal amounts of glucose and fructose through hydrolysis. Because glucose and fructose are sweeter than sucrose, invert sugar is approximately 30% sweeter than ordinary table sugar. Another important characteristic is its excellent moisture-retaining property. This helps cakes, pastries, and confectionery products remain soft and fresh for a longer duration. Invert sugar also prevents sugar crystallization. As a result, products like fondants, candies, and soft fillings develop a smoother texture without forming coarse crystals. The next product is isomalt. Isomalt is a naturally derived sugar alcohol that resembles ordinary sugar but behaves differently during heating. It is highly stable, resists crystallization, and does not caramelize easily. For this reason, professional pastry chefs often use isomalt to prepare decorative sugar sculptures, transparent decorations, and edible showpieces. The final product discussed is artificial honey. Artificial honey has properties very similar to invert sugar syrup. It provides a honey-like taste and appearance while being more economical for certain food applications. A simple observation to remember is that products like invert sugar and isomalt are selected not only for sweetness, but also for their functional properties during processing. Another important group of sweetening agents is artificial sweeteners. These compounds provide intense sweetness while contributing little or no calories. The first sweetener is saccharin. Saccharin is approximately 300 to 500 times sweeter than ordinary sugar. Because only a very small quantity is required, it is widely used in low-calorie food products. However, excessive use may produce a slightly metallic aftertaste. The next sweetener is aspartame. Aspartame is nearly 200 times sweeter than sugar. Although it provides excellent sweetness, it is not suitable for high-temperature baking because heat reduces its sweetness. Therefore, it is mainly used in cold desserts, beverages, yogurts, and similar products. The third sweetener is sucralose. Sucralose is nearly 600 times sweeter than ordinary sugar. Unlike aspartame, it remains stable during baking and cooking. This excellent heat stability makes it suitable for many bakery products where sugar reduction is required without compromising sweetness. Many modern food industries use different sweeteners depending on the final product because every sweetener has its own advantages and limitations. Remember this comparison between aspartame and sucralose as it is commonly asked in examinations. Finally, let us discuss high-intensity sweeteners that are widely used in modern bakery and confectionery products. The first sweetener mentioned is asulfame K. It is approximately 200 times sweeter than sugar and remains stable even during high-temperature baking. Although it performs well during processing, excessive quantities may produce a slight bitter aftertaste. The next sweetener is erythritol. Erythritol is a low-calorie sweetener that closely resembles sugar in taste and texture. It performs well during baking and generally does not produce an unpleasant aftertaste, making it popular in reduced-calorie bakery products. Another important natural sweetener is stevia. Stevia is extracted from the leaves of the stevia plant and is approximately 200 to 300 times sweeter than ordinary sugar. Since it is heat-stable, it can be used in baked products. However, because it does not caramelize like sugar, it cannot produce the same browning effect and is unsuitable for products like meringues where sugar performs structural functions. The final sweetener is neotame. Neotame is one of the sweetest approved food ingredients available, being nearly 8,000 times sweeter than sugar. Despite its remarkable sweetness, it remains stable during processing and does not leave undesirable metallic or bitter aftertastes. With this, we have completed our discussion on the major sugars, specialty sugars, and sweeteners used in bakery and confectionery. If you found this lecture helpful, please like the video and share it with your friends who are studying food technology, dairy technology, bakery technology, or related courses. Subscribe to the channel for more easy-to-understand educational lectures. Thank you for watching, and I'll see you in the next lecture.